Greetings to respected Madam Sir. My name is Pavan Sai, and from the course Design and Analysis of Algorithms, my topic is Vito's family. It's an algorithmic problem. Let's get into it. Coming to the introduction, Vito has several relative living along a street. Each locates at different house numbers. The position of these houses are given as integer values in a list, which represents their locations. Vito want to select a meeting point such that the total distance traveled by all relatives is minimized. The distance between 2 points is calculated using above differences. So this problem is a classic example of optimization in design and analytics of algorithms. It demonstrates how mathematical concepts can be applied to reduce computational complexity. So it it is based on real life situation of choosing the best meeting point. This is very classic optimization problem where we try to minimize total distances. So this problem helps us to understand how mathematical concepts like median are used in algorithms. It is simple but very powerful in terms of applications. Coming to the objectives, to determine an optimal meeting point location, the minimizes which minimizes total travel distance. To design effective, efficient algorithms that avoid unnecessary computations, to upload sorting techniques or structured data processing, to use mathematical insights like median for optimization, to ensure scalability and efficiency for large input size. This main objectives is to find a meeting point that minimizes the total distance. We also aim to design an efficient algorithm instead of checking all the possibilities. Another goal is to sort and mathematical logics effectively. Finally, we want a solution that works well even for the larger input. Going to the problem statement, Vito wants to minimize total traveling distance to his relatives. Each relative lives on this street with a specific house number. A meeting point, which is the house position, it must be chosen. Objective, like minimizing the sum of absolute distance. Input, list of the house position, which is in the form of integer. Output, minimum total distance traveled. Vito has multiple relatives living in a different house numbers of on a street. So each house position is given as an integer. He wants everyone to meet at a single location. The goal is to minimize the total distance traveled by all the relatives. Distance is calculated by using absolute differences. So we need to find the optimal meeting point. So going to the proposed solutions. First, we take all the houses positions as input. Then we sort the position in ascending order. After sorting, we find the median element. The median gives the optimal meeting point. Then we calculate the distance of each house from the median. Finally, we add all the distances to get the result. This approach is efficient and avoids brute force checking. Accept the list of the house position as an input. Sort the house position in ascending order, identifying the median elements for sorting lists. Select the median as the optimal meeting point. Calculate absolute distance of all the houses for the median, sum of all distances to obtain minimum total traveling distance. Use effective sorting algorithms for better performance. Ensure correctness for both even and odd number of elements. These are the proposed solutions. Moving to the features of the systems. The system accepts multiple inputs easily. Due to accepting multiple houses positions as an input value, it automatically sorts the data for processing, and then it identifies optimal meeting points and use medial logic. It also gives the optimal meeting points. The output is accurate and consistent. It ensures minimum total travel distance, so that it identifies optimal meeting points using medial logics a bit easier. Works effectively for large data sets. It is simple and easy to implement. Also simple and easy to understand the algorithm design. Provides accurate and deterministic outputs. It can be extended for more complex problems. For similar optimization problems. Technologies used, we can implement this using C, C++, or Python. For sorting algorithms like quicksort or merge sort, these sorting techniques are used. Arrays or lists are used to store data. Mathematical computation like medial and absolute differences are applied. Um, any IDE like VS Code can be used for development. Standard input output for testing the results. And the basic data structures are like arrays or lists. Going to the workflow. So first, the user enters the house position. Then the values are being stored in an array. Then arrays are sorted in ascending order. Median value is identified. Median is selected as a meeting point. Distance from median are calculated. All the distance are summed. Minimum total distance is obtained. Then the result is displayed to the user. Finally, the minimum total distance is displayed. All the distances are added together. And the advantages, it provides an optimal solution using a simple concept. It is much faster than the brute force method. It is easy to understand and implement. Works well even for larger data sets. Helps improve problem solving skills. Useful in solving real world location problems. Helps in understanding, sorting, and optimizing. Efficient for larger input sizes. It is very simple and easy to implement. It reduces conceptual complexity compared to brute force and improves algorithmic thinking skills. And the limitations, sorting techniques takes a lot of time, especially for the larger inputs. It only works for one dimensional problem. It cannot directly handle two-dimensional or three-dimensional cases. Performance depends on the sorting efficiency. Assumes equal importance for all the locations. Only applied for one-dimensional problem, not directly usable for multi-dimensional data. Handling extremely large datasets may require optimization. Assumes equal weights for all the distances. And the future enhancements, extended solution for multi-dimensional spaces like two-dimensional and three-dimensional. We can extend in multiple dimensional problems. Uses advanced algorithms to reduce sorting cost. Uses faster algorithms to find median in linear time. Apply weight median for the different priorities. Apply and add visualization for better understanding. Integrates visualization for better understanding. Optimize using selection algorithms, ON a median finding. Implementing a real-time processing for dynamic inputs. Expands application for logic and AI based systems. Uses AI and real-time systems. Conclusion, Vito family problem is a simple yet powerful optimization problem. It shows how median minimize the total distance. The algorithm is effectively efficient and widely applicable. It is useful in real world problems like logistics and planning. Overall, it helps building strong fundamental in algorithms. Understanding these problems strengthen concepts and algorithmic designs. It is widely acceptable in real world scenarios like logical planning. This approach is efficient and manageable for the time complexity. It demonstrates how median plays a key role in minimizing distance. So hence Vito family problem is important example of optimization in algorithms. Thank you.